Assalamualaikum warahmatullahi taala wabarakatuh and salam sejahtera. This is part 1 video for chapter 3, the relational database model. Okay, we recall a bit chapter 1 and chapter 2. Chapter 1 is a database concept, right? So you learn that in chapter 1 is about database stores and manage both data and metadata. And you also learn in chapter 1 about the database DBMS, database management system, that manage and controls access to the data and the database structure. Right. So in chapter 2, data models, you learn that the relational data models structural and data independence, which allow you to examine the model's logical structure, right, without considering the physical aspects of data storage and retrieval. Right. You also learn in chapter 2 about the entity relationship diagram, right, which is used to depict entities and their relationship graphically. Okay, so in this chapter 3, the relational database model, okay, you are going to learn some important details about the relational model's logical structure. Okay, and you are going to learn more about ERD, entity relationship diagram, which can be used to design the relational database. Okay, so these are the content that we are going to cover in this video. Okay, we start with the logical view in relational database model. Okay, and what is table and their characteristic, and then we learn about the key in relation model and integrity rules. Okay, next, we are going to cover the data dictionary and the system catalog. And last one is a relationship within a relational database. Okay, basically, relational models enables programmer to view data logically rather than physically. Okay, basically, the significance of logical view is that it can serve a simple file concept of data storage, which is in a table form. Okay, so table resembles a file from conceptual points of view, and it has advantages of structural and data independence in independent tables, okay, which is the table form. Okay, so relational model in table view basically is much easier to understand, okay, than the hierarchical and network database predecessor, which is hierarchical and network models. Okay. Okay, table is a two-dimensional structure composed of rows and columns, right? So it contains a group of related entity occurrences, that is an entity set, okay? Okay, for example, for a student, okay, student table, it contains a collection of entity occurrences, which is each occurrences representing a student, okay? So that's why term entity set and table are often used interchangeably. Okay, so table also called a relation by chord. Okay, chord is relational models creator. Okay, basically chord use term relation as a synonym for table, right? So table can also be called entity set and also relation, right? So these are the characteristics of tables. Okay, number one, a table is perceived as a two-dimensional structure composed of rows and columns. Okay, you can see this example. Okay, number two is each table row or tuple, or call it tuple, represents a single entity occurrence within the entity sets. Each column represents an attribute, and each column has a distinct name. Okay, just please try to understand the statement. Okay, each row or column intersection represents a single data value. Okay, next is characteristic number 5. All values in a column must conform to the same data format. Okay, for example, this student number, normally the student number is a unique and it holds a characteristic type or same data format like a number. Okay, So number 6, each column has a specific range of values known as the attribute domain. Okay. The order of the rows and columns is immaterial to DBMS. Okay. And each table must have an attribute or combination of attributes that uniquely identify each other, each row. Okay, this figure summarize the characteristic of a relational table. You can read this one. Okay, this figure also shows the tables and their characteristic, right? This, for example, here, STU hours, it uses a short form, right? So it should have, each attribute should have a description. For example, here, STU hours, referring to credit hours earned. Okay, STU class is a student classification. STU DOB is a student date of birth, and so on and so forth. Okay. Okay, our next topic is a key, right? Key basically consists of one or more attributes that determine other attributes. Okay, it can be a primary key, PK, which is an attribute, or a combination of attributes that uniquely identifies any given entity. Okay, so key's role is based on determination. Okay, for example, if you know the value of attribute A, you can look up or determine the value of attribute B. Okay, this one, if you practice in the tutorial, then you can see. Okay, just take it as a theory. Okay, so the next one is the attribute B is functionally dependent on A if A determines B. And the other one is determines A determines B can be written as like this. Okay, this is the example. Okay, student number can determine a student name. Okay, so A can determine B, C, and D. So by using a student number, you can determine a student name, student DOB, and student address. Okay, so um, just make yourself familiar with this keyword determinant and dependence. Right? Okay, now is dependency. Okay, basically the principle of determination is very important. Okay, because it is used in the definition of central relational database concept. Okay, known as functional dependence. Right. So, functional dependence is a value of one or more attributes determines the value of one or more other attributes. Okay, so these two keywords, determinant is the attribute whose value determines another, and dependence attributes whose value is determined by the other attributes. Okay, so next is a full functional dependence. Okay, basically, the notation of of functional dependence can be further refined by specifying full functional dependence. Okay, so full functional dependence is referring to the entire collection of attributes in the determinant is necessary for the relationships. Okay. So full functional dependence basically is a condition in which an attribute is functionally dependent on a composite key, but not on any subset of that composite key. So composite key is multi-attribute keys. Okay. Okay, these are the key terms used in relational model. Okay, as I mentioned in the previous slide, it's about the composite key. Composite key is composed of more than one attributes. Okay, just keep in mind that it might be take more than a single attribute, okay, to define functional dependence. And a key may be composed of more than one attributes, okay, which is a multi-attribute, and that what we call a composite key. Okay, so key attributes is referring to any attributes that is part of key. Okay, super key is any key that uniquely identifies each row. So basically, super key functionally determines all of a row's attributes. Okay, for example, here, maybe you can use a student number to look out the data on that rows for all attributes, or student number and student name. Okay, as a super key. All right, so next is the candidate key. Candidate key can be described as a super key without unnecessary attributes or minimal super key. Okay, a primary key is a super key as well as a candidate key. Okay, for example here, student name and student last name is a super key, right? But not candidate key, because student number by itself is a candidate key. So candidate key sometimes uh, confused with a super key, but basically a super key normally hold a unique uh, identity. Okay, I think that's all. Maybe you can look at the more example in a textbook, right? Okay, secondary key basically used strictly for data retrieval purposes. Okay, and then foreign key, an attribute whose values match primary key values in the related table. Okay, if you look at the example, the next slide, you might get better understanding. Okay, you look at these two tables, product and vendor. Okay, you look at the vendor code here. Vendor code is foreign key in a product table. Okay, product code is a primary key for uh, product table. So in this example, there is no secondary key to show you, right? Okay, next is the null. Basically, null's value are problematic in relational model. Okay, a null is the absence of any data value, and it is never allowed in any part of primary key. Okay, primary key cannot be null. It is a no data entry, not permitted in primary key, should be avoided in other attributes, and can represent as unknown attribute value, unknown but missing attribute value and not applicable condition, and it can create problems when function such as count, average, and sum are used. Okay, and it also can create logical problems when relational tables are linked. Okay. Okay, next, control redundancy, which makes the relational database work. Okay, tables within the database share common attributes that enable the tables to be linked together, and multiple occurrences of values in a table are not redundant when they are required to make the relationship work. Okay, this is how we control the redundancy. Okay, redundancy exists only when there is unnecessary duplication of attributes value. Okay, relational schema. Basically, a relational database can also be represented by a relational schema. It is a textual representation of a database tables. Okay, each table is listed by its name, followed by the list of its attributes in parentheses. Okay, the primary key attributes are underlined. Okay, these are the example of a relational schema. Okay, for example, when the table, this is the primary key. Okay, and the rest is attributes. This one also. Okay, this is primary key, and these are the attributes. Okay, relational diagram. This is basically another view of relational diagram where you can see the link between tables. Okay, it shows the links between tables. A primary key of one table appears as the foreign key in the related table. Okay, this one is a unified model language thing. Okay, this is the relational database key definition. I hope that you can read this by yourself. Okay, integrity rules. Okay, integrity rules are very important in relational database. Okay, it is referring to all primary key unique and no part of a primary key may be null. Right. So, referential integrity is meaning that a foreign key contains a value that refers to an existing valid tuple. which is the primary key, in another relation. Okay. Okay, this table shows the integrity rules for entity integrity and referential integrity. You can read, right? Okay, this figure illustrates of integrity rules. Okay, rather than you read the theory, and now you can see how the integrity, entity integrity and referential integrity in table form. Okay, look at this customer table, right? The customer table's primary key is customer code, right? So the customer primary key column has no null entry, right? No null entry. Okay, and all entries are unique. Okay, similarly with the agent tables, primary key is agent code, right? And no null value. Okay, this is what we call entity integrity. So what is referential integrity? Okay, look at the customer table contains a foreign key which is agent code. Okay, which is link entries in the customer table to the agent table, right? So the customer code rows that is identified by primary key number 10013, this one, contains a null entry in agent code, this one. Okay. Okay, this is foreign key with a null value. Okay. So this data shows about the Mr. Orlowski does not have yet the sale representative assigned to him, right? So uh, the agent code entries in the customer table all match the agent code entries in the agent tables, except the uh, 10013. So this is what you call referential integrity, which is foreign key contains a value that refers to an existing valid tuple, which is a primary key in another relation. Okay. Okay, ways to handle nulls value. Okay, basically to avoid nulls, some designers use special codes. Okay, known as flags. All right. So a flag is a special code used to indicate the absence of some value. Okay, if you refer to the figure 3.4 in previous slide, it is an example. Okay, the code here, agent code. Okay, it is related with the figure 3.4. Okay, the code minus 99 could be used as the agent code entry of the fourth row of the customer table to indicate that customer Orlowski does not yet have an agent assigned to him. All right. So if this kind of flag used, the agent table must contain a dummy row. This is dummy row. Okay. With the agent code 99 and contains all the figure, right? I think by practice maybe you can see the how it works, right? Okay. Other integrity rules that can be enforced in the relational model are not null and unique constraint. Okay, not null is can be placed on a column to ensure that every row in the table has a value for that column, or unique constraint is a restriction placed on a column to ensure that no duplicate values exist for that column. Okay, these are the other integrity rules that we can use, right? Okay, next topic is data dictionary and system catalogs. Data dictionary provides detailed description of all tables found within a user or designer created database, right? It contains at least all the attribute names, characteristics for names and characteristic for each table in the system. it contains metadata, which is data about data, okay, and sometimes described as the database designer's database because it records the design decision about tables and their structures. Okay, this is a sample of data dictionary. Okay, all the uh, data dictionary here is referring to the figure 3.4 in a previous slide. Okay, it is for you to get a get picture how the data dictionary for those customer and agent table. Okay. The next topic is the data dictionary and system catalog. Okay. Okay, basically system catalog is almost same with data dictionary, which is contains a metadata, but it describes a detailed systems data dictionary that describes all objects within the database. Okay. Including data about table names, table creators, table date, a number of columns in each table, data type for each columns, index files name, index creator, authorized user, and access privilege. Okay. Okay. Actually, the system catalog automatically produce database documentation. Okay. So when a new tables are added to the database, the the documentation allows the relational database management system to check and eliminate homonyms and synonyms, right? So what is homonyms and synonyms? Homonyms is about the similar surrounding words with different meanings, identical spell words with different meanings. So in database, the use of the same attributes, a name to label different attributes. Okay, for example, customer C name in customer table and C name in consultant table. Okay, this is homonym. So synonym, different names of to describe the same attributes. Okay, in database, say it is same attribute occurs in different table with different names. Okay, for example, auto and car might be a same meaning. Okay. Okay, our next topic is relationship within the relational database. Okay, okay. Basically, we learned about the relationship in the previous chapter, right? So the relationship that we have learned is one-to-one, one-to-many, and many-to-many. So in this chapter, you are going to learn those relationships further. Okay, so that it can help you to apply them properly. Okay, when you start developing database design. So one-to-many relationship is a relational modeling ideal. Okay, should be the norm in any relational database design. One-to-one should be rare in any relational database design, and many-to-many relationship cannot be implemented as such in the relational model, where the many relationship can be changed into two one-to-many relationships. This is what we call a bridge. Okay, so I think in the uh, part 2 video, we are going to learn further on these relationships. Okay. Okay, to summarize this part 1 video, tables are basic building blocks of a relational database, and keys are central to the use of relational database. Okay, these are the key, define a functional dependency, super key, candidate key, primary key, secondary key, and foreign key. Okay, basically each table row must have a primary key which uniquely identifies all attributes, right? So tables can be linked by common attributes, okay? Thus, the primary key of one table can appear as foreign key in another table to which it is linked. Alright. Okay, so good design begins by identifying appropriate entities and attributes and the relationships among the entities. So those relationships are one-to-one, one-to-many, and many-to-many can be represented using ERD. Right. I think that's all for the part 1 video. Thank you.